My name is Michael Brunner. I'm the editor-in-chief of the E&E magazine, and during the whole trade show we talk with important people from the electronics industry about topics that are moving the industry right now. And you can watch us live here at the trade show or via YouTube or our Facebook channel. And right now I would like to welcome Markus Staeblein, General Manager, Smart Grid Business Unit, Texas Instruments. And we will talk about smart grids and smart homes, technologies for more efficiency. Welcome, Herr Staeblein.
Thank you, Michael.
Communication is a very important aspect in the smart grid, but what does that really mean?
So, really, I mean, integrating the communication into the smart grid, it really starts to make the grid, I mean, intelligent and smart. And what that means is you connecting the individual devices, what you have in the grid. It could be an electricity meter, it could be a gas meter, a water meter, or if you look on the grid infrastructure, it could be sensors in substations. You connecting that and give information back to the utility companies. And that is really key, because this is something where now the utility companies are understanding what is the demand of the energy, and they can react and actually increasing the efficiency of the grid. And that is the key point what the utility company is looking in these days.
Which kind of communication technologies can be used for the grid, and what are the advantages or disadvantages?
Okay, that's a good point, because there's two ways what we see on the communication. One is it's called PLC, I mean power line communication. Just quickly explain, that's really when you transfer the data back through the wires, actually where you transfer as well the energy. And the second area is the RF technology, so radio frequency. So these are both technologies, and in both of these areas you have different kind of sub-technologies where, like in the RF, different frequencies. If you look, sub 1 gigahertz is one area. In the US, we see that really deployed already in millions of meters today. But as well as new areas like for in the home, smart homes as well, sub 1 gigahertz Zigbee technologies. And on the power line communication, these kind of technologies, you have standards like G3 prime technologies where you're connecting, for example, the meter with the data concentrator.
So what kind of communication technologies can TI offer? I assume all of them. Maybe you can explain a little bit what you can offer in this area.
That's a good point, because a lot of customers really asking, or utility companies, what should we really use? Should we use PLC, or is RF the right technology? And the good thing first is TI can really offer both technology, and that is very good in the terms of there is always a perfect answer. If you look on countries, it really depends on the infrastructure. If you look in a city, you really, will have some problems with the RF because of big buildings. You cannot putting the connectivity with there. So power line communication would be the right technology in these areas. If you look on smaller town or rural area districts, that's where a lot of RF technology, or even GSM coming into the game as well. And as I said, that's something for Texas Instruments, a very key point, that we come to a customer and provide both solutions in this area.
So it's important to have the communication in the grid, but especially in Germany, there's always a great concern about data security, privacy of data. And how can the customer be sure that only those informations get transmitted that are necessary and that they go to the right receiver?
Oh, yeah. Security is a very key point, and when you communicate data, that is something, and I use again the example between a meter and data concentrator going back to the utility company. And if it's either PLC or RF, it's actually the same challenge you have there. So the key point is you need to make sure you actually encrypt the information. So even if somebody is trying to take this information, or another transceiver, a receiver actually receives this message, they cannot use anything with this kind of information because they don't have the key to de-encrypt actually this. And this is exactly what we're developing in our chips, so in our communication chips. When we send this information, it will be, there is an encryption, and then you need to make sure that the other side, who's the receiver, decrypted it based on a key technology. This is already there today. This is something, a very key point. The next step today, because you will ask me then, oh, what is then secure about the key if I know the key, right? And that is something, what is still, I mean, an attack in the security space where you can maybe open the box, open a meter, or open a data concentrator, and maybe steal even the key. And that is something where also, that's the next generations getting developed in the new technologies, where you have random keys that are not always, I mean, you have the same encryption, and this is something where all the new technologies going into that, to make also the key secure.
Beyond communications and security, what other challenges do we have to face regarding smart metering?
I mean, we mentioned security. This is definitely one of the biggest, but I also want to mention the interoperability and robustness. These are really two key points, and when I talk about interoperability, it's really that you see, looking on the meter side, you have different kind of vendors coming, even if it's a standard, like when we talk about power line communication, you put different kind of meters from different vendors into a grid. What you need to ensure that they're all talking to each other. Okay, we talked about the security, the encryption, but we also, I mean, there is a standard behind that. And so they all need to be interoperable. And there is a lot of activities going on. There are certifications what you have to pass with your technologies. For example, our power line communications, we going to these labs and certifying that we really have the interoperability tests. And the same is the robustness and the quality. We don't want to have, I mean, deploying meters out there and then, you know it from the automotive industry, to recall that, right? So it's really high quality silicon, and as well, I mean, the software what you're putting into that, that's a really key point, that the quality and the robustness is something that needs to be provided by the silicon as well as the metering manufacturers.
TI as a company is also talking about smart homes, which is obviously much more than a smart meter, but what exactly do you mean with the term smart homes, and how do those have an influence on the grid?
So today, everybody talks about the smart meter, but the end consumer, I mean, in the home, I mean, I have a smart meter. I live in Dallas, and but it doesn't help me to save energy or actually impacting it. So that's where we see the next step, I mean, is something that you need to enable the end consumer really to manage the energy, understanding what is your load? I mean, who needs the most? I mean, energy in your house that you maybe can save. You're also getting like solar, or you have a small wind energy source in your home. How do you connect that to your network? Smart thermostats. You maybe decide this evening you're not going home. You have a nice dinner at a restaurant, but your air conditioner is running, right? Can you connect that and tell with your smartphone, for example, saying, I'm not coming home now, maybe 2 hours later, and then your thermostat gets this information and starting to cooling or heating up your home. In-home displays that's showing really, okay, what is my power consumption, and really realizing, is it the refrigerator, I mean, a washing machine, where are my biggest load that I can really save it? Other areas trying as well to have different tariffs, or you have also solar. So what do you want? You want really to use the energy, or when it's actually for free. So when you generate in your home, So you really need a smart home that connects you to the gateway and tells you, oh, now it's the time you run your washing machine, or it's maybe even automatically. So all these kind of activities, this is something where we're looking into it and have solutions for that.
So you already mentioned in Dallas you have already a smart meter, but to me it seems a little bit that smart meters are something taken as naturally taken for granted, but are there any alternatives?
Let me say this way, as long as not every house will generate their own energy and we don't need any utility companies anymore, we definitely need the smart meter and we need the smart grid. It is, if we really want to achieve the efficiency, if we want to have renewable energies that gets integrated and actually getting our CO2 down, we need a smart grid, and the foundation for a smart grid is a smart meter. We need to understand what is the demand in each of the houses or districts to really making sure that we only generating the energy that's needed. Because if you look today, we really burning a lot of energies as well, because the utility companies even don't know, I mean, the demand in the distribution grid there.
Okay, the final question.
Yeah.
Your personal opinion, how will the smart grid develop within the next 5 to 10 years?
I think and I want to splitting this answer in 3 areas. The first thing is on the grid infrastructure. So this is really substation. This is all the way to the end user. There will be a lot of investments in that. Some grids are very old. I mean, from this point, renewable energies will be integrated. So there will be a lot of intelligent sensors getting into this in the grid to make it more intelligent, that you can avoid blackouts. I think the best example was this morning in Munich. I think I would think that you can really have earlier warnings. We're working with utility companies. They have self-healing systems. They have pre-warnings already today in that, and they can actually 93% of the blackouts they can actually avoid because they have this intelligence already in the grid. So this is something what will be developed, I mean, worldwide and even in Europe and in Germany here, that's definitely not. The second, to answer this question on the utility meters, we will continue over the next 5 or 10 years to deploy smart meters. This is definitely a big area, and when I'm saying smart meters, the electricity meter, but also the gas and water meter will be deployed over these next years. And the third area, I mentioned it, the smart homes, smart buildings. I believe, and my opinion is that where people invested a lot in their homes, in furnitures, I believe that a lot of people in the future will invest in energy management, trying to understand, I mean, what kind of energy they use. I mean, having more solar or renewable energies in their home, as well as trying to save energy. And with that, the whole smart home, smart grid will be a very, very big market over the next years.
Ladies and gentlemen, this was the Red Couch Talk about smart grids and smart homes, technologies for more efficiency, live here at Electronica. I would like to thank Markus Staeblein from Texas Instruments for joining us this afternoon. And thank you everybody very much for watching and listening. If you are interested, you can find this interview and all the other interviews we were doing here at Electronica at Publish Industries YouTube channel. Thank you very much.